lower than I expected. So this workshop will last for 3 hours. We're going to have a break at 4 to 4:15. But if necessary, I will stay a little bit longer because I think that I will need more time to do what I wanted to do because the internet is slow. So there's nothing I can do to fix it, which means I'll try to make it as interesting as it should be. But in some moments during my demo, you will have to wait some time for the internet to load or for comments to be sent, etc. So I hope that you will be patient with me today. Yes?
So you need
to do some, we will send some comments on the page that just says, hello, this is me, blah, blah, blah. So I will not show you anything on a specific language because I think that's not the point. Once you know how to run machines and how to manage machines, you can easily use your own web server or your own application server to run your application. So Tomcat, JBoss, Apache, NGINX, whatever you want to use. So I'm not able to load slides, so I'm just going to start right away without slides. But that's not a big deal. Slides were just an introductory thing. So I may connect the video. Let's see if it works. Okay. So there is a, let me move this here. I have to reload it. Okay. Okay. So we'll increase the font size as soon as it gets loaded. This is an interesting situation for me. So how many people are here? About 45, 50 people, I would guess. Okay. How many of you already have an AWS account? Raise your hand. Just 4 of you. Okay, let's do this. Since the connection is not as good as I thought, I will change dynamically the schedule of this talk. And I will try to describe you a few things because I can't load everything, and I will try to show you the most important things on the console or the command line interface. This is going to be less interesting than I was expecting to be, and I apologize for you with this, but if connectivity is not good enough, it's nothing that I can manage or fix right away. So the whole point of Amazon Web Services, well, first let me introduce myself. How many of you were here yesterday during my keynote? Okay, half of you at least. So for the other people, I'm Simone Brunozzi. I'm Italian. I'm 32. I work for Amazon as a technology evangelist. I used to cover Europe. I've been the technology evangelist for AWS in Europe for about 1.5 years. And now I moved to Asia Pacific. I'm based in Singapore. And of course, I cover Asia Pacific. And India, of course, is in Asia Pacific. So what I do is usually give demos or presentations in front of audiences like you. And today I was supposed to give you a very interesting demo on AWS. Why you should be interested in a demo on AWS. Because most of you raise your hand, so most of you are developers. And you already develop your software, your applications for a company or for yourself. Maybe you're a freelancer, or maybe you're just a student. Some students are here. But the point is that when you run these applications, you use hardware, you use infrastructure. You have to. And right now, most of you run infrastructure using on-premise servers and storage. Typically, you have a small data center or maybe just a few machines in your office, and you provide services or web applications on the internet, or maybe you just use them for your own internal use. But the point here is that today, well, since like a few years now, there is a new paradigm that is becoming very commonplace among developers. And this paradigm is called cloud computing. So, as I said yesterday, there is not a specific definition of cloud computing, but what makes cloud computing very interesting is the fact that you use APIs to interact with different services. These services typically provide, in the case of Amazon, infrastructure as a service. So basic building blocks that you can use individually or in combination together to create very complex infrastructures. And a couple of these services, well, I'll mention just 3 of them. The list will be much longer, but this is not the scope of this workshop today. The first service that was launched is called Amazon S3, Simple Storage Service. Think of Amazon S3 as a very reliable and easy way to store your files. So using API calls, typically REST API calls, you upload files in Amazon S3, and then these files automatically are replicated multiple times across multiple data centers in the same region. So Amazon Web Services has this concept of regions: Europe, US East, US West, and very soon Asia Pacific, Singapore in specific. So within each region we have multiple data centers. And the reason why we have multiple data centers is because we want to make sure that if there is any problem on a single data center, which could be a natural disaster or network connectivity which is down or things like that, the other data centers, which are far away from the one that has problems, can still function and operate normally. Which means that when you architect for the cloud, so when you design an architecture to run on Amazon Web Services, you can take advantage of this replication of data centers and run virtual servers on multiple availability zones. That's how we call them. In short, AZ, availability zones. So if you run, for example, 2 servers in 2 separate availability zones, then you can synchronize these servers together. And then, if something bad happens to one entire availability zone, maybe, again, a disaster or a problem with network connectivity, the other data center will not be affected, which means that you will still be able to provide your service to your customers. And this is why it is so important to understand the complexity of like multiple data centers in multiple regions around the world.
So the replication has to be bought by the customer, or Amazon would do it themselves?
You have to do it by yourself, and I'm getting there in a minute. That's a good question. So what happens, for example, with S3, you upload a file, and you use it as a backup or a disaster recovery, or just to host your files, and then you can embed these files into your HTML pages to increase the download speed of your web page, for example. But S3 is just for static files. So S3 doesn't manage any script or any programming language. It doesn't have a compiler. It's just an object store. That's how it is called in technical terms, object store. Instead, if you want to have virtual servers, you want to use Amazon EC2, Elastic Compute Cloud. Amazon EC2 provides virtual servers of different sizes, small, medium, large, extra large, etc. As an example, the small server, for example, with a Linux image on top of it, will have 1.7 gigabytes of RAM, and in terms of computing power, what we call one compute unit. What is a compute unit? A compute unit is a measure that we introduced because if we are talking about virtual servers, and you ask, for example, what's the power of this server, how much it is, the computational power, we can tell you this is a quad-core Intel Xeon 3 gigahertz because it's virtual. There's no point in telling you this is a virtual core of a virtual CPU. So we decided to use a metric that is the compute unit. One compute unit roughly equates to a 1.2 gigahertz Xeon processor. So for example, the medium instance, which is twice the price of the small one, has 1.7 gigabytes of RAM, but 5 compute units on 2 virtual cores. So for you to do the parallel between a medium instance and a real-world server, you can easily think, okay, this is roughly a 2-core, 3 gigahertz Xeon processor. Because 5 compute unit, 2 virtual cores means 2.5 compute units for each core. And if one compute unit is 1.2 gigahertz, 1.2 times 2.5 means 3 gigahertz. Again, this is rough calculations. It's not like exactly that computational power. But again, this is a measure that we try to give to developers to understand roughly what kind of machines they need to run their application. So for example, if right now you're running a Tomcat on a machine that has 2 cores of 3 gigahertz each, you might think, if I use a medium instance, which gives me roughly 3 gigahertz, 2 virtual cores, this should be okay. If 1.7 gigabytes of RAM are not enough, then you should look for bigger instances, of course. So again, we're talking about Amazon EC2 now. You have multiple kinds of virtual servers, small, medium, large, extra large, and then you can decide, okay, I will pick this one, the medium, for example. I want to launch 2 of them, or 10 of them, and I want to launch that specific disk image on that server. Because this is, again, virtual, but you need to start from something. You need an operating system. If you take a real server and you take out the disk drive and you turn it on, it will just prompt you with the energy-saving screen, black screen, and that's it. It will not do anything. So you need an operating system to run a machine. And you can pick a lot of, among a lot of Linux instances or images, or OpenSolaris images, or Windows images. So on the management console, we will see this. We'll try to see this in a second. You can, for example, say, show me the AMI, Amazon Machine images, disk images in short, with Ubuntu 32 bits. And then you will see a list of them. And you can say, okay, I will pick this one, and I will launch 2 medium instances. And then after a couple of minutes, these 2 instances, or 1 or 10, whatever, will be available for you. And this is when things start to become interesting, because you have root access to these machines. You are basically administrator of these machines. You can do anything you want on these machines. You can install your software, configure your things, the same things that you would do on a physical server. So for example, you can start installing your LAMP stack or your Tomcat or whatever platform you want to use. You can move your code. That was the question. You can move your code into EC2. And then you can, for example, every instance has a public DNS entry, which is something like ec2-80-207-81-15.aws.amazon.com, which is a valid address, valid web address, although it is not an IPv4 address, but it's a valid web address. So you can take that address, put it on a browser, and see that you are actually reaching out the web pages provided by that machine. And so in a few minutes, let's say you create your account. Actually, let me tell you something about this, because this is important, because most of you don't have an AWS account. So to use AWS, you need to create an account, an Amazon account. You go there, you say register, you put your webmail, so your email, your name, whatever, and then you create the account. But to be able to use these services, you need also to provide us with a credit or debit card. I know that this is a barrier for some of you, but this is what we need in order to be able to identify you. Because think of this. Let's imagine that we don't ask for credit cards or for other things. You can create an account, launch instances, use these instances to attack a website or to do illegal stuff, and then we can't get back to the person that did this. So to ensure legality and to ensure security, we need a way to identify that person. And we do this using the credit card or the debit card. But then, in your specific case, you can say, I don't want to spend money. I want to try it out, but I don't want to spend money. Well, this is easy for now today, because if I have a web form that I prepared for you, but I'm not sure if I can show this to you. In case, at the end of my talk or during the break, if you come and give me your business card or your email, I will email you with a coupon code, a string of numbers of letters, that gives you $15 of credit to be able to try it out AWS without the need to spend your own money. But this is, of course, a thing that I do here today. This is not available on the website. So you create this account, you put your credentials, your credit card number or debit card number, and then you have your main page, login page in front of you. But right now you can't use any service yet. You should say, I want to use EC2. You click EC2 and you say, sign in for EC2. You want to use S3, you have to click and say, I want to sign in for Amazon S3. And why this additional step? The reason is, when you do this, you accept the terms and conditions. When you create the account, we don't ask you the terms and conditions of all services. This will be a very long list of things and requirements. So when you do this, you do it, when you subscribe to a service, we just show you the terms and conditions, and then when you subscribe, you basically accept these terms and conditions. I'm not going to cover them today because I'm not a lawyer, so basically if you read them, they're pretty self-explanatory. And once you did this, in this specific moment, this is when you can use a command line interface or use a web console to do things with AWS. Let me see if it works. We'll try. Actually, I want to show you something else first. So I'm using a Mac, but this is not a problem. It's, you can use a Linux or a Windows machine. It doesn't count. Let me see if I can do this. This is the main web page for AWS, aws.amazon.com. And I can go here, account, and it will show me, let me move this out. It will show me my account. And here on the security credentials, section, you can actually download your X509 certificate and your private key. You need these two things in order to be able to use the command line interface to issue comments to your AWS account. He asks me to sign in again. I have a memorized password, but it's still loading. Let me see if... And in the meantime, to do this, in order to be able to send comments, for example, I'll show you one comment. Let's say EC2-describe instances. For example, this is one API comment. Actually, I'm using a Java software that I installed that gets these comments and translates them into API calls, in this case, SOAP API calls. And it will give me the description of the instances I'm running in a specific availability zone. So here, for example, I have my access keys. I have my sign-in credentials. I can also use a multi-factor authentication if I need to. And then my account identifier. So when you're here, you click on the X509 certificates. For example, I created a new one today, and you can download the certificate here. Or you can, of course, have multiple certificates available. So what I did, I downloaded my private key and my certificate in a folder. And after doing this, let me see. Bash profile. I also created this bash profile here, in which I basically export some variables, my EC2 home, the path, the private key identifier, the certificate identifier, and the Java framework home to run. Can you keep the lights as I told you? Like, keep the lights high, please. I just want you not to touch the lights at all. Keep the lights up. Of course, restart your bash, and when you did this, you're actually able to send comments from this moment on. And then I just created an EC2 folder in which I have, as you can see here, my certificate, my private key, and bin and lib folders. These folders are the one that I took from the Amazon API tools that I downloaded from aws.amazon.com. And I need this in order to be able to send comments through a command line interface. Of course, I don't need this if I just want to use the management console. Let's look at the management console for a second. So this is the management console, and you can see here that you can use Amazon EC2, Elastic MapReduce, or Cloudfront. And in this moment, we are looking at Amazon EC2 in region US West. I'm not sure if you can read well enough. Region US West. So all the instances, key pairs, security groups, load balancers, all the things that you are managing are specific to that region. So for example, if you want to launch an EC2 instance in another region, you can't use the same key pair because key pairs are tied to the same region. And in this case, we're using US West, which is pretty close, well, relatively close to here. Of course, once the Singapore data centers will be up and running, it will be much easier for Indian to just connect to the Asia-Pacific region. So if we go on the, actually already here, you can see in this right side here that you have 6 running instances, 1 elastic IP, 1 EBS snapshot, 1 key pair, 2 security groups, 1 load balancer. Now, let me explain you what these things are, because most of you don't know about AWS because you never used it. So, EC2, and this is a lot of acronyms, so it's very important that you can understand what they mean. So EC2 is the virtual server. Think of it, medium or small or large virtual server on top of which you can run Linux, Windows, or OpenSolaris. You can also, well, you should run a virtual server using a specific security group. Security groups are another name for built-in firewall. And I'll show you what a security group is all about, because it's very simple, actually. If I click here on security groups on the left side of my console, I will see in this region I only have 2 security groups, the default one and the test one. If I click on default, it will show me that the default group allows TCP connections on port 22 for SSH, port 2306 for MySQL, and port 80 for HTTP. So basically, when I launch an instance belonging to default security group, that instance will have port 22, 80, and 3306 open. Of course, if you have a MySQL server running there, there will be also someone listening to any call to that port. Otherwise, anything on that port would just be, forgotten forever. So when you launch the instance, let me do this together with you. We go on instances, for example, and this will list the running instances I have. You will see that you have the instance identifier, which is I-something. It's here. You have the AMI ID. So the AMI, as I told you, is the disk image. So I started these machines using a specific disk image. Actually, I'm using 2 of them. One is a Ubuntu and one is a Debian. This will also show you what kind of root device you're using. It can be S3, the storage, or the instance store. Instance store means that these images are actually stored on EBS. So what is EBS? Again, a few words about EBS. EBS, think of it as a virtual block device, a hard disk drive. It's virtual, and it's independent from machines that you're running. You can create one or many as you want. Once you created one, you have to specify what size. For example, from 1 to 1,000 gigabytes. Actually, we can even create one. It's quite easy. We go on volumes. Here you have the Elastic Block Store section. Go on volumes. I should have a couple of volumes here. Yes. Every volume has an identifier, a capacity, and when it was created. So I create a new volume. So basically I'm saying I want a virtual disk drive. 1 gigabyte, 5 gigabytes, 1,000 gigabytes, whatever. Let's say 2 gigabytes. And I have to specify what availability zone I'm using. I told you that every region has multiple availability zones. And I also told you that to approximate, every availability zone is separated from the other, which means that if I'm using an attached storage, it doesn't really make sense to have a disk in one data center and the machine reading from that disk on another data center, because performances will be too poor. So when you specify the availability zone you want, you have to remember that only instances in the same availability zone will be able to access this block device. So I use US West 1A. I can also use a previous snapshot. For example, Chow 1 is one of my snapshots, or there are many other snapshots here. So instead of creating an empty one, I can also create a disk that is already populated with data that someone else prepared. And, you know, of course, it depends on what you want to do with that volume. For example, there are some public data sets available. So block devices, EBS volumes like this, with data already pre-built in. So you can just create a new volume and start crunching data without the need to transfer that data beforehand. So now I'm creating a new one, an empty one, and I click Create. And when I do this, in about 1-2 minutes, depending on the size of the volume, I can see the volume created. Actually, I'm zooming too much because, okay, here, now you can see this. Well, you can't see, so trust me. This one says in use, so this means that this volume is attached to an instance. This one says available, which means that the volume is available, but no instance is actually using it, is currently using it. And this one says creating. So the volume is being instantiated right now. So go back to instances. I was telling you that all these instances in this case are running on an instance store, so running on EBS volumes. This means that when you launch these instances, instead of spending like 2 minutes or 3 minutes to boot these instances, you need typically a few seconds, 10, 15, 20 seconds at most. So it's very fast to get these instances up and running. And then what else? So the instance ID, the AMI ID, this is an instance store, and this tells me what type of instance it is, small or medium in this case. They're all running. The life cycle is normal. And there's also the public DNS and the security group, which is default for all of them. You can't read it because I'm zooming the screen and it's not available. Now you can see this. Actually, let me. Okay, and it says that monitoring is enabled as well. I'll zoom back again, otherwise you'll not be able to read anything. If I click on, for example, this one, I can see details down in the page, and this thing will tell me all the details about this instance. So again, the AMI ID, what availability zone it's using. In this case, it's zone West 1A. So again, the EBS volumes that can be mounted on this instance are only the ones that run on zone A. It's a small. The owner is this number, which is me. The projector doesn't really like it, but that's okay. The keeper name is Simone _ US West. Monitoring is enabled, and I'm not using any elastic IP here. This is another term, elastic IP. So I told you before that if you take the EC2 instance with your web server, every instance has a public DNS name, EC2-25-120- blah, 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 .aws.amazon.com. So a very long name. And then a question could be, but what if I want to use a static IP? We provide static IPs. We call them elastic IPs, and there is a reason for this. You can take these elastic IPs. Let me show them to you. They are here, elastic IPs under networking and security. I just have one, I think, or two. I think it's one. I have this one. So when you create a new elastic IP, Amazon assigns a static IP to you. And then you can attach this IP in place of the public DNS for EC2. So for example, in this description, you can't probably read it because it's very small, but it says that this instance is using this elastic IP. If I go back here and I look at this instance here, and I go, let me see, here, this one has a public DNS, so I can reach the instance with this public DNS, but if I use this elastic IP here, I can actually reach that machine as well. This is a simple web page, and actually I just included a number to be able to differentiate different instances that we're using. So you can reach it also using the elastic IP. Why it is called elastic? Because I can map this IP to another instance in real time. It is very easy. So for example, let me do this. If I go and look at this one, this instance here, this one has a public DNS. And if I copy the public DNS and I put it here, it will tell me it works, and this is instance number, I think, number 1. Exactly, this is instance number 1. So if I go back to my web console, this instance ends with EFA. So I go again on elastic IP. I select this one and I disassociate this with the other instance ID. And then once it's free again, it needs a few seconds to refresh, I can associate that elastic IP one. And it needs again a few seconds. And once I've done this, if I take the same IP address, it's pretty slow here, but it's usually much faster when you have a decent internet connection.
So Simone, I have a question.
Yes, let me finish this thing in 10 seconds, and then I will get you space for that question. If I open this, let me refresh. This is instance 1 now. So basically, it's elastic because I can dynamically unmap that IP and remap it to another instance and then do this at my pleasure. What was the question?
Why would somebody have so many instances? I mean, is it for the scalability? Can't I use the same instance to scale it?
Well, that's a good question, but let me open this up and then I'll answer you. So actually, here, luckily for me, because I already prepared this for you, I usually don't keep instances running. And I put these instances here because I wanted to show you a few things, which hopefully I'm going to do possibly after the break. The first 2 instances are in the same availability zone, and actually I'm load balancing these 2 instances. So I'm using the Elastic Load Balancer, which is a feature of this platform that allows you in a few clicks to load balance the web traffic or other traffic on other ports, for example, database traffic, across multiple instances. The 2 others, the 3rd and 4th one, are bigger instances. They are medium instead of small. And I wanted to do a performance test, but actually I don't think we will have time to do this. And I wanted to show you the performance difference between a small and a medium instance, which is 5 times faster in terms of CPU capacity. But actually, when I personally do tests, so keep this with a grain of salt, but it's like it could be different for other people. But when I do tests, it shows me that medium instances are usually 6 to 7 times faster. It might be that, the overhead of other operations, different than the web server, is lower, so that's why it's 6 to 7 times bigger. The 2 others are different instance types. They are Amazon Machine Images, AMIs, that already have a LAMP stack pre-configured. So if you turn them down and turn them up again, you will already have, well, actually, no, let me rephrase this. When you launch a new instance of this type, you don't have to configure Apache, MySQL, PHP, or other things, it's already pre-configured. So the whole point of having thousands of different AMIs is that if you want to do things by yourself, you can take a vanilla plain AMI, like a fresh Debian install or Ubuntu or CentOS, whatever, and then you can install your things, do your stuff, and when you're satisfied, you can easily wrap it up together. We say you can bundle a new AMI. Basically, you can hibernate this status in a new configuration, which is a new AMI. That is private by default, so only you can use it, but you can make it public. And this is why most people here are publishing their AMIs, because they just want to share this with other people. So this is why I'm running all these things. And you asked about scalability. So I have a short video which doesn't require internet connection, so hopefully we'll be able to see that, to watch that. And when we talk about scalability, of course, let me explain, actually, let me ask you, this is a very common question that I have for software developers. So let's do this little game here. How many of you think that they know what scalability really is? Raise your hand. Don't be shy. I mean, you can be wrong. Don't be worried. Okay, so it's about, I don't know, 20% maybe of the audience. So I will tell you what are the characteristics of a scalable system, and when I'm finished, you tell me if you were right or not. Well, actually, I will ask you again, were you right? And you will raise your hand if you knew all these things. So, first of all, a scalable system should have performance increases which are proportional to resources increase. So, if I have this kind of performances with 10 servers, and then I scale up to 100 servers of the same type, my performances should be roughly 10 times better. This is the first characteristic of a scalable system. Second, it should allow for heterogeneous systems. So being able to run, for example, 2 servers of different capacity, of different architecture maybe, and still being able to maintain the other characteristics, like, for example, performance to resources scalability ratio. And this is the second thing. So heterogeneity. Third thing should be, it should be resilient. Resilient means that if I have, for example, 100 servers, 5 of them, 20 of them fail. They break out. They stop working right away. A system is resilient if the users of that system or other applications using that system don't notice the difference. Of course, there will be lower performances, but they don't think that something bad happened. They will just see this is lower performances. That's it. So that's a resilient system. Another important feature is that it should be operationally efficient. And this is very important. If I have 10 servers, and to do that operation, I need 10 seconds, when I have 100 servers, I should be able to perform the same operation in about 10 seconds. This is operationally efficient. Fifth thing, which is probably the trickiest one, the cost per unit should decrease when I scale up. So if 10 servers, they cost $1,000 each, 100 servers should cost less than $1,000 each. And I'm not talking about buying, I'm talking about running, maintaining servers or storage. So the total cost. And these are the 5 things that make a system truly scalable. And this is not humble Simone telling you what it is, but this is Werner Vogels, our CTO. He was at Cornell University. He is famous worldwide for his studies in distributed systems and scalability, and he is one of the key people behind the success of the Amazon.com infrastructure and the creation of Amazon Web Services. So I think that we should pay respect to his opinion. So how many of you were right about this? Raise your hand. 1, very good. 2, very good. 3, very good. So it's like 3 people versus like 20 that raised their hand before. But this is not to, to blame you. This is just a very common thing. Because, and this is a very important point I want you to really understand. What you are seeing today, even if it's not as you expected probably, because I'm not really doing a real demo, but this is something that should help developers think about their role in their jobs and their businesses. Because most developers, up until like a few years ago, were constrained to do some specific things because, and I've been one of them, so I know about it, because you're always limited by resources and infrastructure. And I think that you can really familiarize with me on this. So whenever you say, oh, I have this great idea, or I want to do this extra feature, whatever, then you go ask your sysadmin or your operational guys and say, hey, can I have like 10 more servers? They say, no way. You have to wait 6 months for that. And this is a limit. Right now, instead, what we see is that developers, not just sysadmin, but also developers are starting to use AWS to do their own things, despite the sysadmin are not able to provide them, the infrastructure they want. And this is a big change because it would also change the way you will influence your company, your job, and everything else. So you asked about scalability, how to do that. You do scalability in 2 ways. This is not just AWS. This is general terms. In and out or up and down. This is the 2 ways to scale. So scaling up or down means that the same machine gets pumped in some way. So if you have like a small instance, you want to scale up, you go for a medium instance. You want to scale up more, you go for an extra large instance. You want to scale down, you go back to a small instance, etc. This is how you scale up and down. In and out means the number of servers scales. And in fact, there is a service that we offer, which is called auto-scaling, that allows you to scale in and out, which means 5 servers, then 10, then 20, then 15, then 7, then 35, etc. So you scale the number of servers.
So what happens to software, right? So if I'm scaling up or down, do I have to like kind of move my image again to the new server, which is say a medium or a large, or
yes. So this is the next question that always come up, and thank you for bringing this up. So Amazon takes care of the infrastructure on top of which you run your application. I'll give you an example so I can make it clear how you scale. Let's imagine, for example, a web server, which is a very common use case. Actually, let me make it a little bit more complex. You have, let's say, 10 servers, and you run Apache, PHP, whatever, MySQL on the back end, but we don't look at MySQL for now, just the web servers, 10 machines. And then what you say? You say, I want to make this system scalable. What do you do on AWS? First, you want to load balance across these machines. So you want to say, okay, instead of using my own load balancer, or instead of just using random machines, which is a very poor decision, you can activate a load balancer. And actually, I can show this to you right now. If you go here on load balancers, you will see that I have already one load balancer in place. I called it, with a lot of fantasy, my load balancer. And if you look here, this is the description. This load balancer is acting only on port 80 now, but of course you can configure other ports. Is using 20 availability zones, and it is not using stickiness. And I will explain you what is stickiness later. And also, there is the DNS name of my load balancer. So you remember that I have my instances with a simple web page that says instance 1, instance 2, etc. If I hit the load balancer, for example, this time I got instance 2. If I refresh, instance 1, refresh, instance 2, refresh, instance 1, 2, 2, 2, 2 again, 1, 1, 2, 2, 1, etc. So this load balancer is very easily balancing traffic across 2 instances in this case. And if I go on the instances subsection of this load balancer, I can see that these 2 instances in availability zone 1A are in service, and so they take traffic from the load balancer. And I don't have any instance on availability zone 1B right now. So basically, I'm using a single availability zone right now. So for our example, I can say I create a new load balancer, and then I can assign these 10 machines to that load balancer. And then from that moment, instead of using the individual public DNS or the elastic IP of these machines, I can use the public DNS name of the load balancer. And then it will automatically load balance the traffic for me. But this is not about scalability yet.
So you're going to map the IP to the load balancer's URL, right?
Exactly. And you do this visually or with a single command line command very easily. So right now we have these 10 servers, and they perform they perform well.
So this is in and out, right?
This is no, actually, this is not scaling yet. This is only load balancing. I'm getting there. It's I want to explain every step. But then, of course, you say, okay, in this case, I'm running web servers, and I want to make sure that all these 10 machines provide the same web content, right? Otherwise, it's different websites. And to do this, you come to the application level scaling or load balancing. What do you want to do? You want to have the var www subdirectory synchronized across these machines. You always have static and dynamic content on a web page typically. So the static content is easy, right? If you update the static content, you just make sure you update it on all the local disk drives of these machines. Dynamic content, let's say it's PHP pages generated with MySQL. With a database, let's say MySQL, all these 10 machines, when they generate pages with PHP and MySQL, they query the database, and then they execute the script, the PHP script or Java, whatever it is, and then they present the content. So these machines happen to have the monitoring service enabled. So for example, this is EFA final. So if I go on EFA, I'm already there actually, here. There is a different tab called monitoring. If I go on monitoring, it will give me here graphical information, but I can easily get text information using an API call. And as you can see here, the CPU utilization has been very low. Disk reads very low. Disk writes quite common. And network in and out. So this graph here gives you an idea of how you scale. So let's do this. I have a nice screencast that I want to use now to show you what happens when you want to scale machines. I'm opening it right now. Okay, so I described this. Basically, this is a dashboard that is reading the server count, so the number of machines that I'm using. And I'm now opening up a load against these machines. So I'm trying to simulate like thousands of customers that are hitting the web page. And here I'm measuring SimpleDB transactions. SimpleDB is another service provided by Amazon Web Services. S3 transactions, and basically this is just 3 servers for now. And this graph here shows you the CPU usage. And when the CPU usage is over 90%, for example, this is a threshold I can decide. I can say, I want to auto-scale these machines. And to do that, you just have to put them into the same auto-scaling group with a single API call. And once these machines are in the same pool, you can see that the threshold has been crossed, so it's launching 4 other machines now. And these machines were pending in this moment. And then server count is now 7. So the system automatically launched 4 more machines. And now, since machines are more than double, CPU usage should go down, right? Because the traffic is spread across 7, not just 3, but 7 machines. So you will see here that once the machines are operating, the CPU usage goes down. You see now it's getting down, which is good. But then let's see that this lasts for a few minutes, so it show you a few steps about it. So let's see that, of course, I want to test it against a higher load of traffic. So I pump in more load with a simple simulation, and then the CPU usage starts to go back again to like 90, 95, 100%. And my threshold, it's something that I can decide, says that when the CPU load is over 90%, I want to start 4 more instances. So what it does here, I'm running 7 machines now. 4 other machines are launched. They are pending. It means that they are booting up. And once they will be up and running, this will show 11 as it is. And then very shortly, the CPU load of the average CPU load across these machines will go down again. Now, what happens when I want to scale down? Because, I can't run 11 servers forever if users are not there anymore. So I decrease the traffic, the simulation traffic that I was running. The CPU load would just go down and down and down. You will see this in a second. And then my threshold is like if CPU load is below 50% for more than 30 seconds, you have to kill, I think in this case, 2 instances at a time. So CPU load is actually now 8%, 7%, so very low. And the threshold is being crossed. And so the system will say, OK, I need to shut down 2 machines. So machines will go from 11 down to 9. And then it will keep doing this as long as the CPU load is lower than the threshold I set down. So you will see here that if I refresh, still running, I refresh again. This is 11 now, 11 machines. 2 of them are shutting down. So now it's going back to 9 machines. And then it will go back to 7 machines, etc. But how does this system works? The monitoring tool provides the information. These information are at the hypervisor level. Do you know what an hypervisor is? An hypervisor is a system that virtualizes real hardware and offers higher level virtual servers. We use Xen, X-E-N, as an hypervisor. So the hypervisor controls these machines. It's the same as having sensors on physical servers. I'm measuring like CPU load and disk I/O, etc. The same thing. Of course, we do this virtually. We don't need physical sensors for that. So the monitoring system provides this information. So you can use the elastic load balancing that I showed you before to spread the traffic across multiple machines. And with a single API call, you can put these machines together in an auto-scaling group. Once they are in the auto-scaling group, every auto-scaling group has thresholds, rules. And these rules say minimum number of servers is 5. Maximum is 20. Scale up 2 servers every time your threshold is crossed, or kill 3 servers every time your lower threshold is crossed. With these simple rules, once everything is set up, you basically have a system that auto-scales by itself. But this is the infrastructure, and your original question was, what about the application? What happens to my Tomcat, or what happens to my whatever? So here we're talking about distributed systems that use multiple machines. So you're talking about multiple instances of Apache or multiple instances of MySQL, etc. We saw in the case of Apache or a web server that you actually don't need to do anything specific because the data synchronization happens in the backend. So let's go back in the backend and see how the MySQL thing works. And as you know, MySQL can be run in multiple ways, like master-slave, many different configurations. But the most common thing is to have a master machine and slaves machines. You can enable read-only on the slaves machines to improve performances, but have the single write machine, the master machine, to make sure that you have consistent data all across these machines. Which means that, example, let's say I have 4 machines in the backend with MySQL, and my web servers are pinging me and querying me with data. I have 1 master and 3 slaves. If data doesn't change, it's easy. Read only, I provide data whenever I'm queried. I can support 100, 200, 500 transactions per second. So basically, the number of servers can scale up and down accordingly to the load I have. And again, this works fine. But what happens when data is written? Since I'm using a single master, when data is written, as you know, as it happens in most database configuration, I want to ensure the ACID compliant properties, which means I want my data to be consistent. So when someone says, I want to write in cell A, the system, the master, says to slaves, lock in that table or that record. Let me write. Let me give you the copy. And once the copy is replicated, I remove the lock-in and tell the person the transaction has been completed. Of course, if an error occurs, you use the write-ahead logs and other techniques to revert back to the other situation. But that's not specific to the AWS. This means that the only moment in which you will not be able to get data is when data is written, when data is updated. And if you have a large system, you will see that you will have to decide to compromise between availability of data and the time needed to write updates on this data. And in that case, you might want to use other kinds of configurations, in the case of MySQL, to improve performances. But again, in this case, as you see, I don't really care about the number of machines as long as I have 1 master and multiple slaves. And of course, the master is intended to be separated from the auto-scaling group of the slaves I'm using. If you're using another kind of application, any other kind, the only thing you should think of when you want to keep data consistent is, how can I write data with that application, and how that data is updated and replicated across multiple copies. And this is a huge topic which goes under the name of distributed systems. But in this case, you don't need to know the specifics. Well, like in the case of Amazon, Amazon gives you an infrastructure that can scale. If you want to implement a distributed system, you would have to understand how to implement this, even if you were using physical infrastructure. So there is no difference in the way you do this in a on-premise infrastructure or on AWS. No difference. The difference is that it's much easier, in this case, with Amazon, to scale up and down accordingly to your needs, which means, first of all, you save money. Because if in this moment you need 7 machines, there's no point in running and paying for 10 machines. So you just need the number of machines you actually need in that moment. And then you can scale up and down following your needs. So you can be very proactive in providing very good performances. Did I answer the question? It was a very long answer. But
Yes. I think let's split the question in two, right? One, the database part, where I have some more questions like whether multi-phase commit is possible or not. But on the application side, right? That's where my question was originally.
let's say in a 3-tier architecture, web, application, and database, you want to focus now on the application tier.
Side, right?
Yes.
So if I'm scaling on an application side, or to be precise, as you say, right, either I'm scaling out or scaling up, whatsoever, do I have to do anything specific with respect to the installation of my application? Right? Do I have to reinstall it in the new servers that are dynamically getting added?
Okay, so the common practice is this. You don't reinstall the application because, for example, as I told you at the beginning, you can create your own AMI with your configuration. What you need, however, to do is to take care of the data. Because if you launch a new server, which is already configured with your application server, whatever, but data is not there or is not updated, and you start providing service from that machine, you're actually providing the wrong data. So the only thing you should care of is when you launch a new machine, you should make sure that the data that that machine is using, which could be a database, in that case you don't worry, or maybe other kind of local data, which in that case you should worry, should be updated with the other machines. And most people do this. Most people use the database because the database is intended to solve this problem. This is like typical use for a database. But sometimes you have other situations in which you have like local data or other metadata that you want to use. In that case, EBS comes in play. EBS is the Elastic Block Store, the virtual block device I told you about. And it's very easy for EBS to replicate EBS into another volume transparently while the original volume still keeps working. So if you have, for example, a machine, an application server, and you have a volume attached to this machine can keep using the volume, and then you say, I want to scale. You do a replica of the volume. Will take some time depending on the size of the volume. Once the volume is up and is available, you launch a new machine using your specific AMI with the configuration already in place. When you launch it, you can also give it parameters to say, when you come up, please mount this volume. So you don't even have to log in into the machine. You can make it mount it by default. So the machine will go up, the block device will be mounted, and if it's in an auto-scaling group, in a load balancing group, it will be up and running and start serving customer right away. So serving the web server right away. There was a question here, and then I'll go back to you. Just 1 second. We're supposed to have a break now. I will answer these questions here, 5 minutes possibly. We have a break of about 15 minutes, and then we come back. Well, you can stay, but we'll start back again in about 15 minutes. Please.
Actually, what about this licensing mechanism? Like when we do the scale up and scale down?
Licensing, for example, like Oracle, Microsoft, what kind of?
Yeah, so the Oracle database, if the scale up and scale down and the application.
Yes, so most products available on AWS, they basically offer you, I call it like this, it's my term, license by the hour. And let me explain. For example, let's imagine Red Hat Enterprise Linux. You know that Red Hat Enterprise Linux is a licensed product. You have to pay a license. When you use it normally, you pay some amount of money, and they give you a license, which is usually good for 1 year or 3 years, whatever. With Amazon, you can run Red Hat Enterprise Linux. But then you can say, how can I pay the license if I use it for like 3 hours, right? The license price is added to the by the hour price of that machine. So for example, if you run a small instance, it's 8.5 cents of a dollar. If you run Red Hat Enterprise Linux on that instance, the price is 8.5 cents plus an additional price. So basically, when you scale, the price of the instance also includes the license cost for that hour or these 5 hours, whatever. And this is in most cases. Some softwares, however, they have a different licensing model. And in most cases, our suggestion would be, if you already have an agreement with that company, to like Oracle or Microsoft, and you can't get the license by the hour. Well, with Microsoft you can do that. With Oracle you can do that. But maybe you have another company, like for example IBM DB2. Oh no, they do it as well. Well, there should be an example of a company that doesn't provide you this. In that case, you can bring your own license to the cloud. So you already have a license, you can bring it there. Or if you can do this, you actually have to agree with that company on how they enable you to run multiple instances for like peak times. But for Microsoft, Oracle, Red Hat, IBM, all these like big names, you can run it by the hour and pay by the hour. So basically, you don't even touch licenses. It's very easy.
Does that mean you have separate prices for separate AMIs? And do you have a tie-up with Adobe for Flash Media Servers and Flash Com Server?
We offer Flash servers.
AMI which has this Flash Media Server installed?
So we have them, but we don't have them as AMIs. We offer Flash Media Server in the Cloudfront product. Cloudfront is a content delivery service. So we allow you to stream media with Flash Media Server using Cloudfront. I would like to make the break now. I will show you something about Cloudfront later. So maybe after I've showed you something about Cloudfront, you can actually ask me a more specific question. So 10 minutes break. I don't know what time is it now. It's 16. It's 4:15. So 4:30. Oh yeah, 4:09. Okay. 4:20. In 11 minutes we're gonna start back again.
Try another $50 of Amazon's web service.
You're right. You're right. That's a good. You should do business because you're very good. Okay, so we get back to our situation here. So let me introduce a few things about S3 and Cloudfront, and then we get back to Amazon EC2. I should have a page open. Yes. So this is a plugin for Firefox called S3 Fox Organizer. On the left-hand side, I have my disk drive, and on the right-hand side, I have my S3 buckets. In this case, I'm inside Simone-India, and I have 2 files here stored in Amazon S3. Whenever I want to upload a file, I can easily do, for example, I don't know, I have a picture here. Actually, this is a Twitter feedback. Do you use Twitter? Raise your hand. Few people use it. So I'm Simon on Twitter. So if you want to say anything, just mention @Simon, and then I will answer you. So I select a picture and I uploaded the picture, and it will take some time depending on the bandwidth you have here, and of course depending on other things. It's quite fast though. As you can see, it's uploading here now. It's almost finished. And when it's finished, the file will be private by default. So what this interface is doing is using REST APIs to send a binary transfer, a file, into Amazon S3. Now that the file is uploaded into Amazon S3, it will appear here. I just have to refresh. Oh, it's still processing. Needs a few more moments. Completed. Okay. And it's here. Sorry? Wait, I don't hear you. Say it again.
You're about to tell about the stickiness.
Yes, but later. Now I'm talking about S3. Okay? So this file, if I edit the ACLs, everything is private. So I'm the only one able to do things on this file, but I can enable read for everyone, for example. And then if I take the URL, because every S3 file has a URL, I can easily open it up on a browser, and it will show me it's loading. It will show me this picture. It takes some time because it's slow. Okay, this is the picture, it's loading. But this is getting this picture from Amazon S3. If I want to publish this, sorry, it's here, this file, this content on Amazon Cloudfront, which is a content delivery service, I can easily do it from here or from the management console. I can click Manage Distribution, and then I can comment this distribution. I can say GIDS Workshop. This is just a comment for me to remember what this file is all about. And then I can click Create Distribution. And this is the distribution. And this is the URL for that file. I can save it. So now it's not yet available, so it will not provide me the file yet, because now it is caching that file into edge locations all around the world. So basically, S3 offers durable storage, but if I want to deliver content worldwide, what I will need to do is use Cloudfront. Cloudfront caches the content across multiple edge locations. And then it will serve the content from the closest edge location. For Bangalore, for example, we have edge locations in Hong Kong and Singapore, which are probably the two closest ones. And so if you use Cloudfront instead of using S3, the download rate, the latency will be much better than Amazon S3. And this is, of course, something that you want to use if you have, for example, a website and you want to provide content on that website. And, of course, you want your users to be able to get fast access to that content. We will need a few more minutes for this, so I will try it later. It is almost loaded here. And, of course, you can use command line interface comments for Amazon S3 as well if you need to. But this is a graphical interface that can show you a few things. So, you mentioned that you want to know about the stickiness of the load balancer, so let's get back there first. So the point of stickiness is this. If you have a load balancer and you have, let's say, multiple users access your application, of course, how can you get track of these users? And what happens if, for example, one of these users is using a server and that server goes down? You can have the load balancer generate cookie stickiness. So basically, the user will be able, during a session, to be moved to another server without him to need to do anything about it. This is how stickiness works. Of course, stickiness might not be good for some specific applications, but you can easily enable the load balancer to generate cookies or the application that you run to generate cookies to enable stickiness. Stickiness, of course, is used to keep the connection, the session open with a specific user or a specific application. So that's basically it. So let's look at volumes. If I refresh, if I refresh, this volume should have been created by now, of course, should be available. Yes. So this volume is not attached to an EC2 instance yet. How do I do it? Well, I can easily look, for example, at this volume here, 2 gigabytes. And I can connect this volume to attach volume to one of the instances I'm running. For example, this one ending with EFA, and the device name would be, for example, SDG, dev SDG. I attach it, which means the same as I'm connecting the cable, the virtual cable, to this EC2 instance. But then I have to mount that volume into that instance, otherwise I can't use that storage. So what do? I have to connect to that instance. To connect, I need to know what instance I'm connecting to, which is this one. And I can easily say, right-click, connect, and just get the connection string from this help that is appearing now as a root user. Once I'm in, I should perform a few things. So this is a new volume. So if you click on the volumes, for example, and you click on help, it will tell you what you have to do to format a volume and then mount it to an EC2 instance. So for example, I can do this, mkfs type ext2 dev. It was SDG, I think, right? It's saying this is the entire device, not just a partition. You want to proceed anyway? Yes. Okay. And then I can, of course, I should create a directory. So let's say I can create it in, I don't know, var www Simone. And then I can mount dev SDG into var www Simone. And then I get inside var www Simone. And I'm in the VirtualBlock device now. And I can, for example, create a file. The file is here. Now I can get up. I can unmount. That volume, which means that I can now detach it from that instance. Detach volume. Yes. And then I can attach this volume to another instance. For example, let's say this instance here, it ends with E0. So I take this volume here, I should refresh. It's available. I attach it to the instance ending with E0 as, again, SDG. Now it's in use. So if I exit from the other instance, it's quite slow, yes. I go here and I just get the connection string, which is faster. Then I connect using the key pair, etc. Then I can create a directory, var www Simone, again. And then I can mount dev sdg into var www Simone. And then if I cd into it, I have my chow.txt file that I just created. So as you can see, it's very easy, and this is why it's called Elastic Block Store. It's very easy to manage these volumes and perform specific actions. And another very cool thing about a volume is that it's also very easy to snapshot that volume. For example, I take this volume here, and I click Create Snapshot. It will say, tell me a name for this snapshot. It's very slow now. I'm sure that if you do it from your home, it will be much faster. Description can be GIDS workshop. Workshop. Create. The snapshot is stored in Amazon S3. And why do you need a snapshot? For example, if you want to create a new volume identical to that one. This is the snapshot I just created. I can create a volume out of that snapshot. Now, I can also change the size of that volume. I can make like a 3 gigabyte volume. Maybe I just want a bigger one. I click Create. And then if I go back to volumes, as you see, it is creating a 3 gigabyte volume. Again, US West 1A, the same zone. And once this volume is available, it will have chow.txt file inside it. You can mount it and do whatever you want. Of course, it's plain stupid to just do this with a simple txt file, but think of how can you use it with your application or your infrastructure. For example, you want to run a database. You run the database not on the local storage of a machine, but on an EBS volume. So when the machine goes up, you can say, mount the volume before the MySQL database is started. And then the MySQL database will find the volume mounted on /var/ whatever. And then it will use that volume. So if you want to do a backup of your database, you can easily do a snapshot of the volume. If you want to replicate your instance, you can easily say, snapshot of the EBS volume, create a new volume from the snapshot, launch a new instance which will mount that EBS volume immediately. And in a few minutes, you will have a replica of your database machine immediately. So this is very powerful, and this is very different from what you usually do with physical hardware. So the whole point of AWS is giving you tools and infrastructure services that make your life easier. And now I'm showing you simple examples. A simple TXT page or a simple web page. So the point is not that. The point is you apply this to your situation. It's very different from what you used to have previously. And my suggestion again would be try it out with the code I give you. You will get $15 for free. Try it out and try to see if they apply to your specific situation. In most cases, that will do. So let's have a quick look at, for example, the Cloudfront page that I just created previously. A few minutes have passed, so it should be available. Yes, it is available. And as you can see, it's loading much faster than previously, even if this is still slow. And it is faster because it's using caching edge locations in Singapore or Hong Kong. As you see, it's much faster. So you don't need this, you don't need this, you don't need this, you don't need this, and don't need this. Okay. So this is a simple PHP page that is on one of the instances. It just shows you the instance number and the client address. This is just a test that I used to have on my machines to make sure they work. If I refresh here, I will have my EBS volume up and running, well, available, with a blue light. Yes, it's available. So I think I showed you most things. What you will see doing is that in most cases, oh no, I'm in the wrong console. Should exit. Okay, here, for example, you will have a long list of EC2 related comments that you can use from your console line to send specific comments to your instances. You can delete, you can create, you can describe, etc., etc. It's a long list. And of course, all these things, you can do them using the management console. Another thing I want to show you, since most of you were Java developers, how many of you attended my talk yesterday afternoon on Java? You? Okay. I will show you a quick video. It's not both of them, just the first one. It's a 3-minute video. And it shows you a few things of the Eclipse AWS Toolkit that is particularly important for Java developers that want to develop on AWS. Let me see if I can. Oh, I have audio here.
We're showing off the AWS SDK for Java and some of the integration with the AWS Toolkit for Eclipse.
Let me see if it works.
AWS Eclipse update site, aws.amazon.com/eclipse.
Let me start
From here,
again.
specifically, we're using the Java EE distribution of Eclipse 3.5 Leo from eclipse.org. Specifically,
Okay, sorry, I'm stopping. So this video will show you a quick overview of how to use Eclipse, and of course, how to use the Eclipse Toolkit to manage EC2, well, not to manage EC2 instances, to deploy your application on Amazon EC2. I'll just let the video run for you.
we're
It's 3
using the
minutes.
Java EE distribution of Eclipse 3.5, which ensures we have all the dependencies we need already installed. Then we'll go to Help, Install New Software, and enter the AWS Eclipse update site, aws.amazon.com/eclipse. From here, we see the features provided by the AWS Toolkit for Eclipse. There are tools for managing EC2 resources, working with data in SimpleDB, and integration with the AWS SDK for Java. We'll click through the Update Wizard, accept the Apache 2.0 license, and after everything finishes downloading, we'll let Eclipse restart. Now that we've got the Eclipse tools installed, we see the AWS Toolkit for Eclipse overview page, which we can always get back to from the toolbar button. From here, with the console view, you can see output and logging from the sample as it queries SimpleDB, S3, and EC2. Thanks for watching the screencast.
Okay. So basically, you've seen a very short clip in which you had a hint on how to use Eclipse in specific to interact with AWS. So instead of just doing what I did here on the management console, which is, let's say, the usual activities that a system administrator would do, if you are developing your Java software, or you can also develop in .NET or other languages, you can easily use the Eclipse AWS Toolkit, which is integrated with AWS, to basically be able to, for example, develop some code and deploy it on Amazon EC2 instances, and then watch what they do and update security groups and do other things without the need to ever exit from Eclipse. So most of the functionalities that you see on the management console here are actually available on Eclipse if you install the Eclipse Toolkit. And of course, the Eclipse Toolkit will ask you to get the AWS credentials in it, your X59 certificate, your private key, because that's how we authenticate your requests. One important note is that the management console is usually slower than Eclipse because the management console is web-based, so you don't just have the API calls, you also have some overhead for the graphic and Ajax and all the usual HTML stuff. Eclipse is a little bit faster. So if you want to manage things, there's no point in having Eclipse here and the management console open on another page. Just use Eclipse because it has everything you want to do. In some cases, for example, and this is for EC2, if you want to use the Elastic MapReduce or Cloudfront or other things, Eclipse doesn't support that. So in that case, you will need the console as well. So given the bandwidth limitation, I decided to, as you saw, I decided to give you just a very brief overview of how to do things, how to launch servers. Actually, we didn't launch a server. That's something that we should do now. So for example, let's imagine I want to launch the same server like this one here. This is a plain Ubuntu image. So I can say instance actions launch more like this. And when I say this, it gives me another page, hopefully. Still loading. Let me do this. More like this. Okay. Let me get it back again. Okay. Launch more like this. So in this case, I can also take, for example, a Fedora LAMP server, which has already PHP, Apache, MySQL installed, or a Windows server, etc. Let's imagine I want to launch this one here. It asks me for the instance details. How many instances? For example, let's say 2 of them, medium instances in zone 1B. I can specify a kernel ID or a RAM disk ID if I want to, and I can enable CloudWatch, which I usually do by default. It's very slow. Sorry for that. I'm used to Singapore connectivity, which is way different. So enable CloudWatch. I can use an existing key pair or create a new one. I use my Simone US West. I can use the default security group or create a new one. In this case, I will just use the default security group as soon as it gets here. Choose one or more of your existing default. Okay. And then I can finally launch 2 medium instances. And when I launch, it will close this page here, and I can get back to my instance list. And I will see that now there are 2 yellow buttons. Okay, now you see them here. They say pending. So these two instances are now starting up, and they will be up and running, in this case, in about, I would say, 20 seconds. And once they're up and running, you can easily log in into them, and you can do, of course, whatever you want with them. Let's refresh. Let's see if they're already up. Okay. It's interesting that it takes way more time to refresh this page than to launch two instances. It says a lot about the connectivity we have here. So now they are running, as you can see, even if the web interface is just hanging up because it's too slow here. But if you're slow here, it doesn't affect your instances in Amazon's data centers anyway. So these two instances here are the one that we just launched. Let me refresh. Here it is. You have the URL here, so you can easily test it. You can copy this and put it on a browser page. And in this case, there is a PHP test, PHP info function that gives you all the information about PHP. So quite easy. And of course, you can also see the monitoring since it's enabled. It will need some time to load. So, well, you saw graphs of monitoring before, so that's how it works. Okay, now I would say I would like to have like a Q&A session with you because I gave you most of what I wanted to provide. Like I showed you, well, I explained you what is AWS, what are EC2 instances, EBS volumes, key pairs, elastic IPs, EBS, so elastic block stores, volumes, S3, Cloudfront. So I explained you a lot of things. Of course, that's a lot for you. And my suggestion would be when you're back home, go on the main web page and try to understand more about it because it's not easy to absorb all this information in 2 hours like we did. So now we'd like to have questions from you. We'll do half an hour of questions, and then we'll wrap up. One question there?
Yeah, basically one question about scalability in general. The question is not Amazon specific, but maybe the answer is.
Okay.
Let's say I have a bunch of web servers in a group, meaning they scale automatically.
See, yes.
And I have, let's say,
Bytes of RAM of memory each. I install memcached in each one of these machines, and then memcached will reserve a small fraction of memory, typically 1 or 2 gigabytes, to the local machine, and the rest will be dedicated to a pool, like a memory pool. So let's imagine 68 times 4 means roughly 260 gigabytes of RAM. And then one machine can use that RAM to perform its actions, which means in this case you can take out the limit of memory if a single machine is powerful enough. But then you might say, even if I use memcached, the single most powerful machine is not able to do this. So you can use systems in which multiple machines have access to the same memory pool, which is very delicate to do. Or you can have different master-master configurations in which, for example, database, you can do database sharding. Sharding is quite common, which means you have a data set, a large one, and instead of having a single machine to manage the whole data set, you split it, you partition this data set, and then you have a machine take care, being the master of that fraction of the database. And this thing allows you to, to grow way more than before. But not all databases can be sharded. Because if you think about it, if I divide the data set, it depends on what are the relational properties of different tables. So it's not easy to say I can shard any kind of data set. Next step again, and this becomes very interesting, is the so-called mixed approach to databases. So we are talking about a relational database here. But in most cases, when you have large databases, a tiny fraction of that data set needs to have relational properties. A biggest chunk doesn't. If you want to have a very nice example about this, there is a website, maybe you know about it. It's called Amazon.com. It's a website that sells books and electronics, relatively famous, but quite big. So Amazon.com uses a combination of relational databases and key value databases, in specific SimpleDB. SimpleDB is available for you as well. It's one of the Amazon Web Services. How does it work? SimpleDB gives you API calls that you can use to insert data, and how it works, how it is organized. It's domains, and every domain has a key and values, multiple values. So you can say, let's say one book can have the author name or multiple authors' names, and the same key can be replicated multiple times. So it's not a relational database because you can't have relations between keys, between elements of this database. However, the way it is built, since it doesn't have relational properties, SimpleDB can scale up to petabytes of storage. Tens, hundreds of petabytes, exabytes of storage. There's virtually no limit. And it scales by itself. So, for example, we had a customer, I can't disclose the name of this customer, again, in Europe, that had a similar problem. They had a 1.5 petabyte data set, which is relatively large. But most of this data set was actually didn't need relational properties. So they did a migration program. Basically, they separated the data set into two chunks, like a core database with relational properties and the huge data set which represented like 99% of the storage, which was just a long list of items and values. It was, of course, it was for a data mining application, and they were wrongly using a relational database for that. Once they did this, they migrated that 99% into Amazon SimpleDB. And then, of course, with SimpleDB, the scalability was not a problem anymore. And they were able to manage the small data set remaining with a large instance, which is about 1/5 of the quadruple high memory, large, extra large, Superman, whatever instance. So they were able to use a single machine to manage this part here, and they applied a master-slave policy there with data sync in real time. So basically, it was very simple to manage from that point on. So this is a general problem. Databases are one of the biggest and most interesting problems in computer science. And I gave you some hints on how some customers solved it using AWS. Yes?
So basically the answer is that same solutions are available inside AWS and outside AWS. Sorry, inside AWS and outside AWS.
Yes.
Usually it's an application problem anyway.
Exactly. And the nice thing about AWS is that it was designed to solve these problems, which means, you know, for example, well, these problems are general. For example, if I tell you criminality, that's human nature, that's a human problem, but then how the problem is solved in Iceland or Singapore or Australia. You can apply different things. And in our case, since AWS was born because of Amazon.com, because, you know, we built web services first for Amazon.com. And then we thought, these are cool, let's sell them because other people will need it. So we had a very big use case of Amazon.com with this large website, a huge catalog of books and items and other things. And we needed services that were able to cope with that scale and these kind of problems. So basically, if you look, well, you just had a look today, but if you will try out AWS, you will see that most things are intended to obtain two results. One is enabling you to automate as much as possible. And automation is the key of Amazon's success. Automation is what saves time, saves money, and reduces errors. Because if you do things by yourself, you are human, you can do mistakes. If it's automated and the procedure is correct, I open the door, check. I said to the hostess, check. I did this with the gasoline, check. I closed the door, check. They go through this, and they could say, I know this by memory. I did this 2,000 times. Why am I supposed to go through a checklist? Do you know why the checklist was introduced in the 30s, 1930s? Because if you as a human perform the same repetitive task multiple times, there's something that happens in our brain that changes the way we perceive that task. And after hundreds of repetitions, we become blind to this task list, and we do mistakes. We forget one of these tasks. And in the case of airplanes, it could be fatal. It could be a big problem if you forgot to close the door before departure, right? The same thing goes for automation. This is why if you can automate like scaling or load balancing or these things, you not only save time because you don't have to do it manually, you have your software that does it for you, you can also reduce the errors. And the second thing is about all this stuff here, is that in specific, for example, with Eclipse Toolkit or things like that, you know, developers have their own way to do things. And let's say you start a project, you spend 100 hours, and then you finish your project. But then, if you look at the overall cycle of a product or an application, is not just the developer time. Because when you're finished, you send an email to your sysadmin and say, I'm finished. Please deploy 10 servers because we need to put this application in production. And if you take the whole process, like the idea, the dev and test, et cetera, the production, the post-production, etc., there are many things. Is in most cases, you solve some problem the same way you would solve in your previous setup, but with different tools, which in most cases are easier to manage. So, 3-tier architecture. You have a database that is exploding in size. How you solve it, you have specific ways to do this. But if you want to do like the SimpleDB thing by yourself, first you need to use or purchase a key value database. Second, you need to run machines, and maybe tens or hundreds of machines for that key value database. And are you able to run machines efficiently? Are you able to run machines effectively? To do it saving time and saving money? Probably not. This is why it's easier to do things on AWS. Any other question? One here.
I have not personally experienced a virtual environment.
Okay.
So my question is, how does unified communication servers, work when they are in a virtual environment like AWS? If we host our unified communications of everything, will we be able to make use of all the features, or there are some limitations?
No, it's no limitations in specific. And actually, there's also another service that we launched 2 weeks ago. It is called SNS, Simple Notification Service. You might want to look into that. I don't want to spend time on this because there are tens of services, and we could easily spend the night here if I was to cover all of them. Look for this as well, and you might see that some functionalities of a typical unified communication system are provided by SNS as well.
And the other thing is that if I am opting for a Windows server,
Windows, yes.
so I'll be able to, would I be able to use PowerShell as I use in,
Yes,
say,
yes,
in-house this thing?
yes, of course.
I'll be able to use the PowerShell in the same way.
Exactly,
There is no difference.
exactly.
Thank you.
Yes.
Can you touch upon the DR across zones, disaster recovery?
Oh, yes. That's a very good one, actually. So disaster recovery across zones. And actually, this is, again, a typical common problem that, in this case, you can solve in a much easier way with AWS. So, typical scenario. You have servers, 3-tier architecture, whatever it is, web, application, and database, storage, and something bad happens, so you want to do a disaster recovery, DR. Typical DR means that you want to restore the operations as soon as possible without losing data. In a traditional infrastructure, DR is very expensive. You can guess why. Because to be able to fail over, you need a spare capacity that just sits there unused, a full waste of money. And then when something bad happens, you just want to redirect the traffic or whatever it is to the other machines. But the problem is that if you're using, for example, the same data center for your normal and spare machines, if the entire data center fails, you don't have a DR. You can't fail over because the entire data center is affected. This is why Amazon Web Services provides availability zones in the same regions, which means separated data centers with multiple tier 1 bandwidth providers. So you can run, for example, servers here, and you don't run anything here. You want to do a disaster recovery. You just make sure that data is replicated and updated constantly, also on the second availability zone. And then if something bad happens here, you can use the monitoring, you can use many ways to detect if something is wrong in this zone here. You can use the elastic IP. For example, if it's entered into your DNS CNAME, you can remap the elastic IP to machines here. You can easily launch them, get them up and running in 20 seconds, mount the Elastic Block Store that has already data updated, remap the elastic IP, and here you have the disaster recovery. And the cost of the disaster recovery solution on AWS is much cheaper than a normal one because the only redundant thing that you pay is the storage. Of course, you want storage to be there because of performances. Because if this data center goes down, you can't be sure that data is still accessible from another data center. So you want to replicate data across multiple zones. But other than that, you don't need to run machines. You don't need to own machines. If a problem arises, You just launch new machines here, you mount the storage, you remap the elastic IP, and all of a sudden, your users or whatever will just go on the new machines. And here's the disaster recovery. And actually, I have a nice story of a customer that did the disaster recovery in Europe, the European region. They were running on zone A. They did a DR on zone B. They just stayed on zone B. They didn't move back because they had servers up and running, and they said, it works fine, that's it. They kept a new copy of the data in zone A, and they are now ready to do a DR back in zone A if needed. They didn't even have to. And another nice thing, DR, when it happens in real world, you say, okay, let me look at this mess because I have servers and storage that are burned or whatever. With AWS, nothing like that. Because if you stop using servers there, you stop paying for that, and you don't have to do anything. Amazon takes care of that. So you don't have to resell servers or fix things. You just launch new servers, and you don't care. It's something incredible. So in a previous life, in a previous job, I was basically the CTO of a university in Italy, sysadmin, network admin, CTO basically, for 2 years. And I was responsible of the local data center, so trust me, I know how painful it is to manage things like physical servers and physical things, and how easy it is to manage things on AWS. And in fact, by that time, I was playing, and I was hoping that someday I could have been able to vMotion. The question is equivalent. Do you have an equivalent of VMware vMotion? We don't. So when you run a machine, there's no way to move that machine somewhere dynamically. No way. But I would argue with you that, and this is again personal experience plus the experience of our own CTO, Werner Vogels, because if you need to dynamically move a machine, is it easier or more difficult than just move the data? And there is a huge discussion about this, and a huge debate. And there's not black and white here. I think it always depends on the situation. We don't offer this, and this is, of course, a bad point for you. But in most cases, we think that if you design for the cloud, there's no need to do this. And in fact, Amazon itself is offering this and is having this, let's say, this approach to cloud computing because of its experience. So think of Amazon.com. 100 million customers, credit cards, transactions, distributed in many countries worldwide. This is a real-world scenario, and people solved these kinds of problems inventing AWS. So there should be something good about AWS. And then, of course, it depends, because there are some use cases in which you might need something like this. So I'm not saying that's wrong. I'm saying in most cases, if you think, oh, it doesn't have this, so it doesn't work for me, make sure that it is not a real limitation, but just your mental attitude that has to change.
So if I'm designing for the cloud, is it that I have to make my application stateless most of the time so that it doesn't hold any data in memory?
In most cases, you move the stateful part back to the back end. That's a typical approach.
I think one of those things we were contemplating within our solutions is like the memcache, the EH cache and the terracotta product.
Mm-hmm.
So it's like at the VM level or at the app level, we try to leverage terracotta, and then if one of your instances fail, sort of seamlessly.
Yeah, of course.
To another one.
Of course, that's a way to do it. But again, this is all about architecture. And I think that if you have an existing application, which specific, not problems, like specific needs, like yours, like in your case. If you want to move it to the cloud, you want to do it because you like the flexibility of a virtual infrastructure. However, you might need to rethink the way, for example, you manage states in your application. And in most cases, from what I've seen, when you move in the cloud, you try to move the statefulness back to the backend. That's a general, of course, this could be a very long discussion. I'm just giving you a very simple and synthetic approach to this. Any other question? One there? Yes?
What kind of application server AWS supports? Like if you are using through Eclipse?
So what kind of application servers?
Which application? No, I mean Tomcat or WebSphere.
Yes, Tomcat, for example. Yes, it's available. What else? Tell me some names. I'll tell you if they're available.
WebSphere.
Yes, WebSphere, yes.
Directly in the EC2 will be having the WebSphere?
Exactly. Actually, for example, many IBM products are available because IBM is a partner of Amazon Web Services. So there are also Amazon machine images, for example, with DB2 already installed. You can launch the instance, 1-2 minutes, and you will have a fully fledged, they mostly use CentOS. I'm not sure what flavor of Linux. I think they use CentOS with DB2 already installed, for example, and configured. So it's very easy to do this. Yes?
Yeah, so the load balancer which we talked about, is it user location aware? So basically, let's say if I make a load balancer having instances in Europe and I want to, and in America.
So load balancer is only limited to the region. Okay. You can't use it cross-region.
Okay, so it's already.
Yeah, you can use it across multiple availability zones, but in the same region. AMIs, yes, of course. Question is, can you customize AMIs? You should, actually. It's not can, you should. And it's easy, you can do it in many ways. One way is you take a basic AMI provided by Amazon. Well, actually, sorry, there are many more ways. So one is you can build an AMI from scratch. Second is you take a running EC2 instance and you bundle it into an AMI. And of course, the process is quite simple. Actually, I also have a link for you, which is this one. If you go on elastic.com, let me write it down for you. Not this one. If you go here, this is a website maintained by Eric Hammond, which is a software engineer based in California. He's also a partner of Ubuntu, Canonical Ubuntu. And he provides AMIs, updated AMIs for Debian and Ubuntu. And he has a very interesting blog in which he publishes information, for example, like this one, how to create, this is the one I was mentioning, a new image for EC2 by rebundling a running instance or building EC2 images from scratch. In this case with Ubuntu, but of course you can do it with other tools as well. So these two articles will be very good for you. Actually, let me do one thing before I forgot, because this is something, I have two very good suggestions for you, very important ones. So I'm still paying for these machines. So I have to take them and terminate them. Otherwise, I would keep paying. And trust me, when you use this for the first time, it will just, go to lunch, go away, and you will leave instances up and running. Then at the end of the month, you will see a bill of like, $50, $100, and you say, oh, what happened? Oh, My EC2 instance. Yes, it's like, keeping leaving the gas open in the house when you leave. And trust me, this happens to 50% of people that use AWS. So remember to terminate them. I was almost forgetting, as you see. You also pay for volumes. So actually, I'm doing the same thing for volumes. I will delete, well, actually, these two I can't now. We'll delete these two. And then I will take these two and delete them as well. And then it takes some time. And then I go back to snapshots. I select both of them and delete them. And then I go back to elastic IPs, and then I disassociate this elastic IP. So basically, I go back to my EC2 dashboard. Of course, I have to refresh this. Sorry? Oh, Zoom, sorry. Oh, yeah, of course. So this will tell me how many running instances, how many, oh, I zoomed too much. How many EBS volumes, key pairs, etc. One load balancer, I forgot about this. So actually, you have to zoom out again. I go back to my load balancers and delete this load balancer, yes. Okay, now I go back to EC2 dashboard, refresh. I still have 4 EBS volumes. I think it's deleting them, and it doesn't have finished. It will need a few more seconds. Exactly. Now, as soon as the 4 EBS volumes are shut down, I stop paying anything for AWS. Exactly. Utility computing. I'm still paying a little bit for S3 because I have some files there, but the cost is like, I think I have half a gigabyte in S3, personal things. Cost is 15 cents of a dollar per month per gigabyte. So basically, I pay $7 a month.
But what if you have your custom images created, like the AMI?
So when you create a new AMI, you pay for the storage, but the AMI is usually compressed. So, for example, a typical Linux AMI is 200, 300 megabytes. So every month you pay 4 cents of a dollar.
And that is not in my account listed, it's in Amazon.
No, if you create a new AMI, like your own, you are paying for that. 4 cents, 5 cents a month is like a very small amount of money. Yes?
My application, I can't use
Simple DB, yes.
features of my application. So I can use all features, like multiple joins, some complex queries, everything I can do, or I have to compromise some relation database.
Wait, you have to speak slower and
I can still use all features of MySQL with this cloud computing, or I got to compromise some of the features, like multiple joins. And
no, you can use all the features you can use on a normal MySQL.
Okay, and I have gigabits of data. What about the migration from my?
Well, it's easy. You can do a dump.
Yeah, but you have to pay something for that?
Well, when you do the dump, so let's imagine you're running MySQL on EC2. Usually you do the dump in the local storage in most cases. If the dump is big, you can do the dump on Amazon S3. In that case, you would pay for the storage. So if you do like a 100 gigabytes dump into Amazon S3, that month you would pay $15 for that. No, because data transfer from S3 to EC2 is free in the same region. If you do across regions, you pay because you go across the internet.
And suppose I'm doing some batch processing.
Batch processing, yes.
Customer data.
Uh-huh.
Once done the data, when with the service, where goes my data? You will destroy them with them?
Well, for example, Hadoop, what kind of processing?
It may be a normal batch processing.
Well, if you store that data into Amazon EC2 in the local storage, when you shut down the machine, the data is lost unless you do a backup. So in that case, you have to do a backup on S3, or easier, if you use EBS and you store your results on EBS, EBS is persistent. So if the machine goes down, EBS doesn't lose data. Okay? How secure is your data? So for Amazon, security and operational excellence are the two most important things. Amazon.com itself, you know that we have 100 million credit cards, which means security for us is very important. The same kind of approach for security is valid for AWS. And in fact, there is a security section on the web page, on the website, in which you can download a security white paper that gives you all the details about security. My suggestion would be get that paper, download it, and then see the details. Too many questions for you. I want to get other people. Actually, it's 5:34, so I would take 2 more questions, these 2, and then we wrap up. First him. Oh, it's okay. Yeah.
How is the AWS services different from the on-demand? And follow-up, why you should go for AWS?
Excuse me. You have to shut down, otherwise I can't hear. Okay? Say it again.
How is the AWS services different from on-demand, and why we should go for AWS compared to what the facilities Google is giving?
So it is on demand, basically. So you use resources whenever you need them. So it is an on-demand service. When you talk about comparison with other companies or other services, my suggestion, NASDAQ, Washington Post, New York Times, the European Space Agency, Facebook, all these big names are using us. So I think there is a reason if all these Netflix, all these companies are using us. So try to understand the different options that other providers give you, and then you will decide what works best for you. Last question. Yes, S3 Fox.
S3, thank you.
S3 Fox.
Yeah, to have S3 basically as a virtual hard drive.
Yes.
Is there any tool to connect S3 as an actual network drive on Mac, Windows, whatever is there?
Well,
like a Samba share or anything else?
There are clients that use S3 to do this. For example, Dropbox uses S3, but you don't see the S3 files, you just see names of files inside Dropbox. To mount, let's say, S3 into your local computer, laptop, there is not a single product. There are many ways to do bytes. And it's synchronized across multiple computers using Amazon S3. So it has the durability of Amazon S3.
Okay, and basically all Dropbox files will anyway be stored in AWS.
Exactly.
Okay, thanks.
Exactly. Good. So thank you very much. I apologize for the bad connectivity. It ruined the whole thing, but I tried to give you anyway a good overview of what AWS is all about. As a follow-up, I got some emails from some of you, and you will receive the credits. If some other people want credits, just give me the email now, and I will take it happily. And if you want to comment or get in contact with me, the best way would be using Twitter. I'm Simon on Twitter, S-I-M-O-N. Very easy to remember. So just go there and say something. And thank you very much for your attention. I wish you a great weekend, and to me, a nice flight back home to Singapore tonight. Thank you very much.